step 9 is to make efficiency decisions. So in this step, we're going to look through the different parts of the different columns and how the database is organized and see if there are more efficient ways to be able to store the data. So some of the things to consider is how large is the data. You want to focus specifically on really large data since that takes up a lot of space, or data that's repeated many times. So do you have the same value repeated many times? Is there a different way that you can set that up? Now notice that this particular one will become an issue with security questions. We don't have security questions in this scenario, but we do in a couple of our other scenarios. And if we have a number of security questions that might be used over and over and over again by users, then it becomes significant to repeat those questions every time a user uses it. Rather, it would be more efficient to store the questions one time, make sure they give them each an ID, and then you can store the IDs when the questions are used, just based on the size of the data itself, the question itself, compared to how big an ID would be. So that's something to consider if you have a value that's repeated many times. It becomes more significant when if it's accessed all the time. If you have something that's accessed a whole bunch and it has to be, there's joins included to be able to access it, then that's an expensive access time. So we want to make sure that we're looking at the time to access data. And even sometimes you get to the point where you denormalize to be efficient. So you make sure your database is normalized, and you go back, and if there's an efficiency decision that needs to be made you might even denormalize it if you have good justification. Now that's an important part when you make efficiency decisions. Every time that you make a change based on efficiency, you want to be able to document the justification. Why is it that you made a change? So let's look at these things and see what we have in here. Do we have repeated values? Do we have large data? Notice our biggest data is the description of the courses, and we made this a varchar so it can be as small as possible. So it'll only be as big as the description needs to be. We did that with title as well. So we used varchar every chance we had an opportunity to minimize the amount of characters that would be stored. What about repeated values? Do we have any values that are repeated? Notice here that we have department. This can be null, but it also can be up to 8 characters big. And there's a department listed for every instructor. And department is also listed on every course. So we could think about now, would it be cheaper to list those departments individually and then use an ID when we want to refer to that department in the user table or in the course table? So an ID would probably be a small int, which is 2 bytes big. And how big would a department be? Well, for computer science, it's 2 bytes big because it's 2 characters. So there would be no savings for that department. For art, where it would be 3 characters, there would be a little bit of savings. And for math, that's 4, there'd be even more savings. So if you look at that and you see that most of the departments are 2, 3, or 4 characters, and you'd be trading that storage in for 2 characters for an ID, then you can see that you would save a little bit of storage, but not a great deal of storage. And then the other thing you want to consider is the efficiency. Every time we refer to department, if we move it to a separate table, then there's a join involved. And so then that would increase the cost of accessing it. So we save a little bit of storage, we increase the time for access. In this particular case, I'm going to make the decision that that's not efficient enough to save, that the time to access is a higher cost than the actual time, the amount of storage space saved. So we won't make any change to the department in that particular case. So there's other things to consider. We don't have any other repeated values here, so we'll move on to the next set of things to question, and that is computed values. And we have 2 computed values, GPA and class standing. When you have computed values, you need to consider, do we compute them every time they change and then store the result? Or do we simply compute them when they're needed and we don't actually store them, but we just do the computation whenever they're needed? So here you're talking about 2 different things again, the cost of storage to store it and the efficiency of the cost of computing it. So how efficient is that? So we want to look at how much space to store it and how often the value is accessed and how often do you have to compute it. So let's look at GPA. And GPA is a decimal value, but it's a relatively short decimal value. So this decimal value would be stored in about 5 bytes each. And so there's a GPA for every student, every user that's a student. So that's a lot of GPAs, and those would be 5 bytes big each to store. So there would be some storage cost if we choose to compute and store them. Then let's look at the efficiency of it. So what will be the cost to compute it? Well, if we compute it every time it changes and store it, that would be this first option, right? Every time it changes and then store it, it will change, GPA will change every time there's a grade posted, right? Whether it's a grade first being posted or whether it's a grade change happening. Every time a grade is changed for a user, then that GPA would be recalculated. So how often would that grade change? Well, every semester, a grade changes for every course. So if you're in 4 or 5 courses, then that GPA is going to change 4 or 5 times a semester. You want to compare that then to how often would you be accessing it, which would be the other option. You compute it only when it's needed. So how often would that GPA be needed? That would happen every time a student looked at their GPA. How often do you look at your GPA? Maybe once or twice a semester. Maybe an advisor would look at your GPA maybe once or twice a semester. So let's lean big, so we allocate plenty of time thinking about it. So maybe 4 times a semester, we add a couple, maybe registration needs to look at it, I don't know. So let's say maybe 5 or 6 times a semester that it would have to be computed when you need it. And computed to store it was about 4 or 5 times, right? So the time to compute is almost the same. And then the difference then just becomes the space, and there's more space required if you're going to compute and store it. So in this case, computing it only when needed becomes the most efficient way to do that. So we'll make that decision on GPA. Let's look at class standing. Again, when does class standing have to change? If we're going to keep it updated and compute and store it, it would change. We'd have to look at that every time a class is completed. Again, this would be when that grade's posted, right? So every time that happens, and we've already determined that's 4 or 5 times a semester. And what about compute only when needed? How often do you look at your class standing? Probably significantly less than you look at GPA, maybe just a few times a year. So compute only when needed then becomes also maybe more efficient to just compute when you need it and not store it. So on both of these, we'll make the decision to compute only when needed. Let's see what else we need to make decisions about. Okay, once you've made these decisions, then you need to make sure you make any changes needed on the diagram and document those justifications. So our 2 efficiency decisions are on GPA and class standing. So if we look at the document for this, right, we still want to leave GPA and class standing in our table diagram so that we can see that those are attributes that are available. They're identified as being computed. So they still fit here on the diagram, and we want to leave them here. But now we need to add the justification. So what we want to do here is make sure we put right justifications for every change we made. So here I'm adding one. Computed value of GPA will not be stored but will be calculated when needed. This is because it is not accessed often compared to how often it would be needed to be updated to keep it accurate. Same thing, very similar for justification for computed value of class standing will not be stored but will be calculated when needed. This is because it is not accessed often compared to how often it would need to be updated to keep it accurate. So there's our justifications on the diagram, and we leave those computed values there. Now, if you made some changes for moving something to a different table, like a question to its own individual table or department to its own individual table, then you would update that on the diagram. You would create that new table. You would make the connections where they needed to be made based on what relationship they are. Oh, look, I have a folded. These are tricky to get rid of these things. I have a folded multiplicity there. I want to make sure and get rid of that so that stays really clear. Okay, so there I've added the justifications. Now let's talk about our what we need to do with our physical details, right? Our physical details. And this is really listing our tables and the details to be able to create the tables. And so since GPA and class standing will not be stored in the database, we will actually remove these from the database and from our physical details file so that we don't add those to the table when we're creating those tables. So go ahead and remove any computed values that you decide not to store. If you're storing them, you need to leave them there because you'll need a field for them in the actual database in that table. So that's what you do to be able to figure out those efficiency decisions. So you make the efficiency decisions, make the changes needed on the diagram, and always document justifications for any changes that you make.